Hello, this is Richard Collins, your instructor in ATM 101 Weather and Climate of Alaska here at the University of Alaska Fairbanks. Today I want to discuss problem 1 in the practice exam for the first midterm exam. Each question in the exam starts with 5 multiple choice questions, A through E. Then there's a question based on a diagram, F, and then there's 2 small narrative questions, G and H, in the exam. It's important to do the problem in the order it appears because the multiple choice questions begin you thinking about some of the ideas that appear later in the problem. So it is a tightly crafted problem that explores your understanding around a single topic. Problem 1, the topic is the Earth's atmosphere, where we discuss its composition and structure. In discussing the solution, I will identify the right answer, and then I'll give a little bit of discussion to explain the understanding behind the problem that you may find useful. Problem 1, Part A. The primary source of oxygen for the Earth's atmosphere during the half billion years or so appears to be, the answer is 2, photosynthesis by plants. Photosynthesis, where plants exhale, if you will, oxygen into the atmosphere, drawing in carbon dioxide and releasing oxygen. The other 2 answers, volcanic eruptions and exhalation by animals, are concerning different gases in the atmosphere. Volcanic eruptions are associated with outgassing and are the source of nitrogen in the atmosphere. Exhalation by animals is one of the sources of carbon dioxide in the atmosphere. In fact, plants and animals are in a balance where plants absorb carbon dioxide and animals release carbon dioxide as part of the carbon dioxide cycle. An important aspect of this problem is it relates to the idea that biological processes, or life on Earth, is part of what makes the atmosphere habitable and supports life on Earth. This is a great, if you want, deep question about how life exists on Earth, that life creates oxygen and oxygen supports life. Problem 1, Part B. In a volume of air at altitudes below about 80 kilometers, equivalent to 50 miles, 78% is occupied by blank and 21% is occupied by blank. The answer is number 1, nitrogen and oxygen. The 2 other answers, hydrogen and oxygen, and nitrogen and water vapor, are wrong. Hydrogen cannot exist in the atmosphere because it is released to space because it's so light the gravity of the Earth won't hold on to it. In number 3, water vapor is an important gas in the atmosphere, but it's only abundant in about 0 to 4%, and we'll talk about this a little bit more further down. C. Which of the following statements is true? The answer is number 2. The amount of water vapor varies with geographic region. Water vapor is a variable gas in the atmosphere. It can vary between about 0 when it's very dry to about 4% when it's very humid. So it is the 3rd most abundant gas in the atmosphere when it is humid. Number 1 and number 3 are wrong. Number 1, the amount of water is constant everywhere in the atmosphere. That is not correct. It is highly variable, and it's because water can condense out of the atmosphere and evaporate into the atmosphere. It's due to the changes of phase in water that it is variable in the atmosphere. Nitrogen and oxygen are relatively constant everywhere in the atmosphere. Carbon dioxide is relatively constant, but not water vapor. Finally, number 3, water vapor does not exist in the atmosphere, is just wrong. It does exist in the atmosphere, and it's a very important part of weather, and it's also a very important part of biology. D. Which of the following statements is true? The true statement is number 2. On the top of Mount McKinley Denali, you are above half the air molecules in the atmosphere. What we mean by this is that if I stand on the top of Mount McKinley Denali, I'm at an altitude of about 5 kilometers, and I'm about a pressure of about 500 millibars. You know that the pressure on the ground is about 1,000 millibars, so you're at a pressure half of the pressure on the ground. This means that the weight of the atmosphere above your head is half the weight of the atmosphere on the ground, and therefore only half the atmosphere is above you while half the atmosphere is below you. Therefore, on average, half the air molecules in the atmosphere are below you and half of them are above you. If we look at number 1, on the top of Mount McKinley Denali the pressure is greater than the pressure in Fairbanks. This cannot be true because the altitude of Mount McKinley at about 5 kilometers is much greater than Fairbanks, which is about 156 meters. Number 3, on the top of Mount McKinley Denali you're above all the air molecules in the atmosphere, is not true because the atmosphere gets thinner with height but never quite gets to zero on the edge of space. It is not like the abrupt transition at the top of the ocean where we have liquid water, and so we're never above all the air molecules in the atmosphere. E. Which of the following statements is true? Air pressure in the atmosphere always decreases as we travel up from the ground. Similar to how we are in a swimming pool, when we dive deep in the water, if you've got a sinus headache or you just feel the pressure on your ears, you know the pressure is much greater deep in the pool than as you ascend through the pool and come up to the surface. And the reason is you're just passing in the atmosphere through the air. There's less atmosphere above your head as you go up, and therefore there's less weight. Air pressure in the atmosphere always increases as we travel up from the ground is not true, and air pressure in the atmosphere remains constant as we travel up from the ground also cannot be true. We now turn to part F of problem 1, and I'm going to jump to figure 1 in discussing the problem, and you can backflip to the actual question if you want to see how it's written out. Figure 1 is a plot of the temperature profile of the atmosphere plotted in Kelvin and Celsius as a function of altitude in kilometers. The first problem was to identify the 4 layers of the atmosphere, and these are, starting at the bottom, the troposphere, where the temperature decreases with height as we generally expect. B is the stratosphere, where the temperature now increases with height due to heating in the ozone layer. C, which is the mesosphere, where the temperature again decreases with height. And finally D, where the temperature increases with height in the thermosphere. The atmospheric pressure is going to be highest in the atmosphere, where there's least atmosphere above our heads, and so the atmospheric pressure would be lowest at number 1. The tropopause is at the top of the troposphere, and so the tropopause would be found nearest to number 4. A temperature inversion is where the temperature increases with height, and an example of a temperature inversion is in number 3. The stratopause is at the top of the stratosphere, and that's that maximum there, pointing at number 2. And all of our weather is found lowest in the atmosphere in the troposphere near number 5. Part of the reason for this is weather is driven a lot by water vapor. Water vapor, as it rises in the atmosphere into the cooler and cooler atmosphere, will condense and fall away, and it doesn't pass very much into the stratosphere. Some of it does, but very little. And so it's in the troposphere where we have by far most of the water in the atmosphere, and therefore most of the weather. We now come to the 2 narrative questions at the end of problem 1, G and H. There were 10 points each. These questions come with multiple question marks, so as you answer them, make sure that you stop at each question mark and answer the question. The first one, what are the principal gases in the atmosphere? The principal gases are the main gases that are most abundant, and the principal gases in the atmosphere are nitrogen, 78%, and oxygen, 21%, and water vapor, about 0 to 4%. Everything else in the atmosphere is less than 1%. The second question, where do scientists believe these gases have come from? It's important to note that the modern atmosphere is not the same as the Earth's early atmosphere. Nitrogen was released from rocks by outgassing during volcanic eruptions. Because nitrogen does not dissolve in water and is too heavy to escape to space, it became a major gas in the atmosphere. Oxygen is released as a byproduct of photosynthesis of plants and has become a major gas as plant life increased and is at about 21%. Water vapor, released due to outgassing and also introduced by comets and meteorites, which are water rich, and there's some controversy about how much water vapor comes from the outgassing, from these rocks in the earth where water was trapped, versus how much comes from comets and meteorites. That's an active research problem. Problem H. What is the difference between weather and climate? Give 2 examples of meteorological statements that refer to the climate of the region of Alaska where you live. Give 2 meteorological statements refer to the weather in the region of Alaska where you live. Weather is the state of the atmosphere at a given time and place. It's what's happening in the atmosphere at this instant. It has several components: temperature, pressure, wind, humidity, precipitation, cloudiness, and visibility. There are 7 components. Climate is the average of the weather conditions over several years, typically about 30 years. And the reason for about 30 years is because climate science began in the 1970s when there was a stable climate record from World War II over about 30 years. The joke is that if you're a tourist, you can think of climate as what you expect on your vacation and what you pack for, while weather is actually what you show up and what you get, and can obviously be a surprise. Climate statements about Fairbanks. In Fairbanks, the summers are warm and sunny. In Fairbanks, the winters are very cold, typically about minus 40 degrees in early January. Weather in Fairbanks. In Fairbanks today it was minus 4 degrees at noon. That's just the temperature at an instant in a given place. In Fairbanks today it was overcast at noon. You can find climate statements in the climate of Alaska, in the discussion of Alaska, but I suspect that you can think them up just from your experience. In finishing the discussion of problem 1, which concerns the Earth's atmosphere, I just want to point out some topics we didn't maybe discuss explicitly that are worth considering for the real exam. The script that I've shown you here is taken from a previous midterm exam in another year that I gave the class. One of the discussions of the composition of the Earth's atmosphere is how it's changing, and one of the big issues for us in modern times is changing in greenhouse gases, carbon dioxide change, and also ozone change due to the ozone hole. If you look at that material carefully, a part of that discussion is the idea of cycles, that the amount of carbon dioxide in the atmosphere isn't just fixed, just like the amount of oxygen in the atmosphere isn't fixed in terms of the individual molecules. Plants are creating oxygen while animals are absorbing oxygen, and so there's a balance, and on average the amount of total oxygen remains constant, but individual oxygen molecules are moving back and forth between plants and animals all the time. Similarly, for carbon dioxide, you have a cycle, and similarly for ozone, you have a cycle where ozone is created by ultraviolet radiation, but it's also lost by ultraviolet radiation and also chemical reactions in the atmosphere. So I would also ask you to look at these topics that we've looked at in the problem, but also look at topics of cycles in the atmosphere as well in order to prepare for the exam.